Hello AP Physics students, it's Mr. Ellis, and in this video I'm going to show you quickly how to solve a compound circuit problem. Compound circuits involve both series and parallel components, and in this situation you really need to know what those mean in order to draw it in the first place. So let's look at this carefully. We have a 1.5 volt cell or battery. There's a 100 ohm resistor, then there's 100, and then there's two resistors in parallel, and then there's that 560 ohm resistor. Oh, and there's a switch here. There we go. So 560, 330, 100. Okay. Now you can see that the 100 and the 560 on the left, they're not exclusively in series with each other. There's other stuff in the way. These two, though, are exclusively in parallel. There's nothing else in the way, so we can try to start there to find the equivalent resistance. That's this 1 over, that's the parallel part, right? And then the two series guys, 100 and 560, are right here and right here. So you can do this just in one step, or you can do it in several steps, but this just shows you how to do it the most quick way, where you just do it in one step, set up the formula, and solve for the equivalent resistance. Once you know that, the current through the cell, through the battery, right, is going to be dependent on that overall resistance. Like, it's going to split up. The current is going to go, have kind of a split effect here in the parallel parts. So that's going to be a little different, but through the battery itself, that current is determined by the entire circuit. So you just use Ohm's law. This funny symbol here is otherwise known as EMF. It's just the total voltage provided by the battery. So you get 2.04 milliamps. Easy. Now, if you want to know the current through one of these parallel resistors, like this guy, where the current has split up, it's a little bit tougher. So what you have to do here is actually follow some steps to figure out how much voltage that resistor experiences, like what's the difference in electric potential on the two sides of it. So there's different ways you can think about doing that, but here's the approach I use in this problem. So in this problem, you know the parallel part has the same voltage across both, right, because they're in parallel. Now, you just use Ohm's law, going to be the current through the parallel part, which overall is the same as this current here, because that current, if you consider the parallel part to be one thing, right, it goes through the battery, through the 100 ohm resistor, right, this is the battery, there's a 100 ohm resistor, and through this equivalent parallel part right here, right, the parallel part, that is the same current IT that you had before. Just one way to do it. There are lots of ways you could go about solving this. But if you want to find the total, voltage across the parallel part, you can use that total current, the total resistance of the parallel part, which is 77, and then you can solve for the voltage. Once you know the voltage difference across the parallel part, you can just use Ohm's law. That just shows you where that came from again. And if you want to know the current through that one resistor, you use the difference in potential for that resistor, which is the same for all the parallel stuff, divided by its resistance value, and you can solve for the current through the 330 ohm resistor. So that V equals IR, that Ohm's law, applies not just to the entire circuit, but to each individual part. So it's kind of like a logic puzzle when you solve these things. There's different ways to do it, but this is a way you could follow when you're solving these problems online. All right, thanks for watching, guys.